What if the Big Bang was not the beginning of everything, but the moment our universe appeared inside a black hole? It sounds like pure sci-fi, but it comes from a real question in physics. Black holes and the early universe have something strange in common. Both push our theories to their limit. And once you notice that, the idea becomes hard to ignore. First, a quick reset. A black hole is not some giant cosmic vacuum cleaner. It is a region where space-time is curved so intensely that once you cross a certain boundary, called the event horizon, there is no path back out. The horizon is not a wall or a surface. It is more like a one-way border in cause and effect. Outside it, escape is still possible. Past it, every future path points deeper inward. In classical general relativity, that inward journey leads to a singularity, a place where density and curvature blow up and the math stops behaving. Most physicists do not treat that as infinity is real. They treat it as a warning sign. It means classical relativity is no longer enough, and some deeper quantum description should take over. Now compare that to the Big Bang. In this standard picture, the universe began in an extremely hot, dense state and then expanded. That model works very well. It explains the cosmic microwave background, the abundance of light elements like hydrogen and helium, and the large-scale evolution of the cosmos. But it still leaves one uncomfortable question. Did the universe truly begin there? Or is that just where our equations stop making sense? That is where the black hole universe idea enters. Maybe what we call the Big Bang was not a beginning from nothing. Maybe it was the inside of a black hole, where collapse in some larger parent universe did not end in a singularity, but instead bounced into a new expanding spacetime region. That is the core idea. A collapsing star in some larger cosmos forms a black hole. From the outside, it looks like a black hole. But on the inside, instead of ending in a mathematical dead end, spacetime transitions into a new expanding universe. In that picture, our universe could be the interior of one of those black holes. Why do people even take this seriously? One reason is that black hole interiors in relativity already behave in weird ways. Inside the horizon, inward, starts acting a bit like time. You cannot avoid moving toward smaller radius any more than you can avoid moving toward tomorrow. So the geometry already hints that black holes are not just simple holes in space. Their interiors are their own strange spacetime regions. There is also a tempting scale coincidence. Very roughly, if you take the mass energy in our observable universe and ask what Schwarzschild radius corresponds to it, you get a value in the same general neighborhood as the cosmic horizon scale. That is not proof. It is only a provocative hint, but it is one of the reasons the idea keeps resurfacing. To make the idea more than a poetic analogy, you need new physics at extreme density. Some models replace the singularity with a bounce. In Einstein-Cartan gravity, for example, space-time can have a property called torsion, linked to particle spin. At enormous densities, that can act like a repulsive effect and stop total collapse. Instead of a singularity, you get a rebound. In some quantum gravity-inspired models, something similar happens for different reasons. The collapse reaches a limit, and the interior opens into a new expanding region. If that is true, black holes may not be just endings. They may be cosmic seeds. That leads to an even wilder possibility: baby universes. Every black hole in a parent universe could create a new universe inside it. Physicist Lee Smolin pushed this further with the idea of cosmic natural selection. If each baby universe inherits slightly altered physical constants, then universes that produce more black holes create more offspring. Over many generations, that could make the multiverse drift toward laws of physics that are especially good at making black holes. It is a clever idea, but it is still speculative, and that is the key point here. Right now, there is no direct evidence that our universe was born inside a black hole. The standard Big Bang model, especially the modern Lambda CDM framework, fits observations extremely well. Any black hole origin theory would have to reproduce all of that success and then do even more. It would need to predict some extra signal, maybe subtle patterns in the cosmic microwave background, maybe a distinctive gravitational wave signature, maybe some clue from how extreme collapse behaves. So far, nothing has clearly confirmed it. And there is another problem. If our universe really is the inside of a black hole, the outside may be permanently hidden from us. Horizons block direct information. So even if there is a parent universe beyond our own, we may never see it directly. At best, we might only detect faint fingerprints left in the earliest moments of our own cosmos. So could the universe be inside a black hole? Maybe. Physics does not rule it out. Some serious models make room for it. But right now it remains an idea, not a discovery. Still, it is one of the most fascinating possibilities in modern cosmology. Because if the Big Bang was not the start of everything, but the birth of spacetime inside a black hole, then every black hole in our sky might be more than an ending. It might be the beginning of another universe. If this helped, like and subscribe for more fast space explainers.